Welcome back. Moving on in Module 3, Topic 2, Lesson 2, Activity 2, page 417. Solving addition equations. It says you have now solved one-step equations. A one-step equation is an equation you can solve using only one operation. Model with mathematics and use appropriate tools strategically are our habits of mind. And it says you can use reasoning to determine the value for the variable that makes an equation true. You can also use properties and inverse operations. Inverse operations are pairs of operations that reverse the effects of each other. For example, subtraction and addition are inverse operations, and we also know multiplication and division are as well. We've been talking about that all year. That's a terrible multiplication sign. You worked example, solve the equation h plus 6 equals 19. Before we do that, remember the additive identity property states that for any number, they're calling it m, if we add m plus 0, if we add nothing to the m, it still remains m. In other words, when you add 0 to any number, it stays the same. It keeps its identity. Okay, so they used a double number line, so we have h plus 6 equals 19 is what the original equation was. They subtracted 6 off, took us back to h and 13. You can use inverse operations to solve for h. So instead of using the double number line, this is how they are showing it. So subtracting 6 from here and subtracting it from the 19. They draw a line. This 6 minus 6 is 0, so we have h equals 13. In Mathia, they show it to you going left to right. So when they ask you what operation you need to do and you put a subtract 6, it'll put it up here in a straight line. It means the same as this. This will be the preferred way to write it. This is how you'll have to do it in Mathia. So then it says, what is the solution to h plus 6 equals 19? Well, it says h equals 13. And then it says to check the solution. So we put the 13 in for the h. 13 plus 6 equals 19. Then actually do the addition. Don't assume it's correct. 3 plus 6 is 9. And then we have the 1 equals 19. It is correct. Which property was used to maintain equality? So subtraction. So basically, if we take 6 off this side, we have to take 6 off this side. It's like keeping that seesaw balanced, right? You can't take like 6 people off if it was a gigantic, not a balance beam, seesaw. If it was a gigantic seesaw, you wouldn't take 6 people off one side and not be able to take off 6 people off the other, assuming everybody weighed the same amount and it stay level. So you would have to take off the same amount. Are there other solutions? Are there other solutions to that? So is there another number that we can add to 6 to get to 19? No. There is no other number that adds to 6 to equal 19. Pause if you need to. Use the same strategy to solve each equation. So t plus 24, so the inverse operation of addition is subtraction. So we're going to subtract 24 from each. So here we have just the t equals 5 minus 4 is 1, 8 minus 2 is 6, 61. Checking our solution, 61 plus 24 equals 85. 1 plus 4 is 5. 6 plus 2 is 8. 85 equals 85. And it checks out. Remember, in Mathia, it will look like this. They'll have this. And you will fill in, you'll say minus 24, and it'll populate it like this right next to it. So it still means the same thing. It will then give you t equals the 61. So it is essentially the same thing. Okay, So here we have 12 plus m, which is the same as m plus 12. Once we start adding negative signs on things, then it'll change the way we rewrite this a little bit, but for now, we are okay with setting it up like this. So we're going to subtract 12 from both sides. So we have m equals 5 minus 2 is 3, 3 minus 1 is 2. So m equals 23. So again, in Mathia, it'll look like this. The minus 12 will show up here and here, and then it will show you 23 equals m. To substitute it back in, we have 35 equals 12 plus 23. Then you actually do the 12 plus 23, 2 plus 3 is 5, 1 plus 2 is 3. And it is correct. Okay, and we're going to see you on the next video.